So in example 2, suppose we have a company profit decreasing at a fixed rate each month. So here's the profit decrease function. It's the derivative of the profit. R of t equals negative 2,000. It says over here it's in dollars per month. Notice there is a little typo right here. The x-axis should be labeled t months, not t years. So for example, at month 0, profit is decreasing $2,000 per month. At month 1, profit is decreasing $2,000 per month. At month 2, profit is decreasing $2,000 per month. Go up to month 5, profit is still decreasing $2,000 per month. I don't know the actual profit. All I know is the rate of change of the profit per month. It is fixed, it's constant, it's always going down at a rate of $2,000 per month. So our question is, what happens to the profit during the first 5 months, during that first 5-month period? So again, if I were to ask you during the month 0 through month 5, what happened to the profit overall? Well, you might logically just say, well, we take 5 months times a decrease of $2,000 per month, which would equal negative $10,000 total. We're not saying profit is negative 10,000. We're saying during that first 5-month period, profit decreased a total of $10,000. It is an accumulated change in the profit from month 0 through month 5. Let's think about that on the graph. We have our rate function, the derivative of profit given. If I want to know the accumulated change from t equals 0 up to t equals 5, one way we can think about that is like an area between our x-axis and the rate function. Now, area is a geometric concept that always is positive. If we find the area of this rectangle, base times height, so it'll be base 5 months times height. Height of this rectangle is 2,000. However, the difference here between finding an area and finding an accumulated change is we need to understand that accumulated change may be negative, and in this case it is. On this entire span, the height of the function is actually negative 2,000. So when I write the height here, I'm actually thinking about the height of the function. The height of the function is negative $2,000 per month. Notice that does correspond to this height, this length of this graph, this rectangle, but we must understand that if it is below the x-axis, we count that as negative. Even though it's a length, we're counting it as negative because we're actually finding accumulated change of the original profit function, and that definitely can be negative. The profit could go down. Since the rate function is negative, the derivative is negative, it means the profit was decreasing on that span. So we count that accumulated change as negative. So I think of this as base times height, where the height is actually negative. So the months on the top cancel with the months on the bottom. I multiply it out, I get negative 10,000. And the units are dollars. It's not saying that the profit is negative $10,000. It's saying that from month 0 to month 5, the profit decreased a total of $10,000. And again, it's like this area between the rate function and the x-axis, but because it's below the x-axis, we count that height as negative. Now let's think about that on an actual example profit function. We have 2 of them here. So one possible original profit function is this one. P of t equals negative 2,000 t plus 10,000, where it's saying at month 0 it has $10,000 of profit, and each month it goes down $2,000 per month. The second example starts at 30,000, so it's P of t equals negative 2,000 t plus 30,000. Each month it goes down $2,000, but this one starts at a profit of 30,000. So they look different, but by the time month 5 goes by, this original function up here in example 1a has $0. Here, by the time month 5 goes by, it's down to 20,000. But you'll notice, for each one of these, 5 months goes by, it decreases $10,000 in profit. This one started at 10,000 and went down to 0. The second example started at 30,000, but as 5 months goes by, it decreased $10,000 down to $20,000 of profit. But again, I didn't have to have the original profit function to identify that it went down $10,000. The accumulated change over that 5-month period, we found that using the derivative of these functions. So when given that derivative function, r equals negative 2,000, we were able to take the area between the rate function and the x-axis, count it as negative because it's below the x-axis, and that told us the accumulated change in the profit.